Module 4, Session 2. Session 2 will cover the following content. Learning Outcome 2.4.2. Find the derivatives of various functions. Learning Outcome 2.4.3, first part. Use the constant, sum and/or difference rules for differentiation. Learning Outcome 2.4.2. Find the derivatives of various functions. Before we move on to the rules for differentiation, it's useful to revise the different notation that can be used for derivatives. It's important to always use the correct notation and symbols. For example, if y equals f of x, then the derivative can be expressed in different ways, such as the derivative of f of x, or simply f prime, or y prime. The derivative of y for f of x. The derivative of y with respect to x, or it can be expressed like this. This table expands on the notation and symbols. If the notation y equals x to the power n is given, then both sides of the equal sign can be differentiated with respect to x. If the notation is f of x equals x to the power n, then the differentiation notation must be in the form of f of x or f prime with respect to x. Finding derivatives from first principles can be quite time-consuming. Luckily, the derivatives of most functions can be determined using a set of rules called the rules of differentiation. The rules of differentiation are simply generalizations of applying first principles, so they are much quicker to use. Students at Level 4 will need to understand the differentiation rules from Level 3 again. All of these rules are given on their formula sheet, but they should know the first three well, so that they can apply them without looking them up. The first three basic rules are the constant rule, which states that the derivative of any constant is just 0. The power rule, which tells us how to deal with powers of x. In the derivative, the power becomes a coefficient and the power of the variable is reduced by 1. And the coefficient rule, which tells us that if the values of a function are multiplied by a constant, then the values of the derivative are multiplied by the same constant. The exponential and logarithmic rules are new in Level 4 for students. The exponential rule for differentiation is quite remarkable, as it shows that e to the power of x is its own derivative. When we differentiate the natural log of x, the result is the reciprocal or multiplicative inverse of x, thus 1 divided by x. The trigonometric rules are also new to students in Level 4. Let's take a look. If y equals sine x, then the derivative is cos x. Similarly, if y equals cos x, then the derivative is sine x. And if y equals tan x, then the derivative is sec squared x. All of our basic rules can be found on the formula sheet for paper 1. Let's watch some examples using the rules for differentiating functions.
It is important for the Level 4s to take note, especially when it comes to differentiation as well as integration of the formula sheet. All problems related to differentiation starts from formula number 4 right up till formula number 20. And it's very, very important that, and I will even encourage that, you use your formula sheet all the time. Let's look at the following examples that I have here in front of me. Calculate dy dx if, then we look at number A, y is equal to x to the power 7. In other words, that is a power. Immediately when you look at that one, you look at formula number 5. D with respect to the x, xn is equal to n xn minus 1. Let's look at A. Y is equal to x to the exponent 7. Obviously, from formula number 5, dy dx will be equal to, they said n. N is your exponent, then x, exponent reduced by 1. In other words, your answer there will be 7x to the power 6. Let's look at B. Y is equal to 3x to the power 6. We're going to apply exactly the same rule as before. dy dx is equal to, let's keep the 3 there, and then use a square bracket. And then obviously exponent x, exponent minus 1. And then simplify. 3 times 6 is equal to 18x to the power 5. Right, so for A and B, we have applied formula number 5. Let us look at C. C is equal to y is equal to ln x. That is a logarithmic expression. If you look at your formula sheet, you will see that formula number 11 speaks about if y is equal to ln kx, then dy is equal to k over kx. Now, if you're looking at this one, this is exactly the same as y is equal to ln 1x. So, k in this instance is then equal to 1. So, dy dx will be equal to, based on the formula sheet, k, which is 1 over x. Let's look at number D. Hey, D, y is equal to a. If you're looking at, let's just go back to a. Y is expressed as a function of x. B, y is also expressed as a function of x. C, y is also expressed as a function of x. Now you're looking at D, y is equal to a. There is no x on the right-hand side. That means that a is regarded as a constant, which is exactly the same as formula number 7. dy dx, I always said, is equal to 0. A nice way of remembering it, y is equal to no x. That's why dy dx is null, 0. Let's look at the following questions. Differentiate with respect to x. Aex. Obviously, I will say it is advisable to write y is equal to ex. Now, this is a straightforward exponential expression. And you look straightforward on your formula sheet, formula number 13. And if you look at formula number 13, then you will see dy dx is equal to ex. In other words, the derivative doesn't change. Let's look at B. Y is equal to sine x. This is a trigonometric ratio. If you look at your formula sheet, formula number 14, dy dx, the derivative of sine x. Learners don't need to study this. They can just read it. Derivative of sine x is equal to cos x. No problem. Let's look at C. Now, another way, instead of writing y, you can write the function of x is equal to 3 cos x. Now, to find the derivative, we write it as the function slash x is equal to, you keep the 3 as a constant, you use a square bracket, you go to formula number 15, the derivative of cos is minus sine of x. And then you just multiply it out. 3 times minus gives you minus 3 sine of x. And then look at D. Y is equal to 2 tan x. dy dx, what is the derivative of tan x? You just go to your formula sheet. Dy dx is equal to 2, formula C, derivative of tan x, sec squared x.
Learning outcome 2.4.3a. Use the constant sum and/or difference rules for differentiation. The next rule that students need to learn is the sum and difference rule, which they should have learned in level 3. This states that when you want the derivative of a sum or difference of two or more terms, you differentiate each term separately. This rule should be applied whenever there is more than one term in a differentiation question. Let's look at a teaching tip on differentiation.
Differentiation, the people normally say it's very difficult. I tend to disagree. Because if you differentiate, the very first and most important thing is you ensure that the expressions are in standard form. And that's the problem. Because they don't take notice of the three no's. There must be no surds. And the surds becomes a fractional power. There you have standard form. There must be no brackets. When you remove the brackets, then you get standard form. And there must be no variable as part of the denominator. Example, 1 over x to the power 3. There they gone. Then they say differentiation is difficult. Whereas 1 over x to the power minus 3 becomes x to the minus 3. There's it in standard form. Formula sheet, and you differentiate. So they don't take note of the three no's. No brackets, no surds, and no variable as part of the denominator.
On your own, quickly work through the following examples, applying the basic rules and the addition and subtraction rules combined. Let's have a look at the solutions for these questions.
Differentiate with respect to x. Y is equal to ax squared plus bx plus c. This is an application of the sum rule. One very important thing to remember about differentiation is you can only differentiate once your expressions is in standard form. And if you look at standard form, it's formula number 5, x to the power n. It is formula number 7, which is the derivative of a constant is 0. And if you look here, in other words, all your terms must first be in standard form before you can differentiate. Ax squared plus bx plus c. Now let's look at each term. X to the power 2, that is standard form. B, x to the power 1, that is standard form. C, which is no x function, that is standard form because it is regarded as a constant. Which means I can straight away now find the derivatives. Dy dx is equal to a, and then exponent x exponent minus 1, right? Plus b. Remember, if there's nothing there, it is regarded as exponent 1. So 1x 1 minus 1. Plus, obviously, c, there's no x, the derivative is 0 because that is regarded as a constant. And now you're just going to simplify. 2ax plus bx x to the power 0 plus 0. Finally, that is 2ax plus, obviously, anything to the power 0 is 1, that is b plus 0. Some people might wonder why I write the plus 0. Very simple, because you get a mark per derivative. Now sometimes if you don't leave it out, which is correct, but the marker can slip, taking in note to give that extra tick, and by means of that you might lose marks unnecessary because of human errors. Let's look at B. Now, exactly the same. Sum rule, exponential, 1 over x, sine of x. In other words, exponential, power, and a trigonometric ratio. This one is fine, but that one, remember when it comes to differentiation, there must be no variables in the denominator with regards to the sum rule. No variables in the denominator. It's one of the no's. There are 3 no's, but I will explain it as we apply it. There must be no variable as part of the denominator. So the first thing is we need to express this in standard form. The function of x is equal to 2ex. I will just write down plus 1 over x plus sine of x. 1 is okay, exponential 2, so in other words, I must first write it in standard form. 2ex, I can read the derivative straight from my formula sheet, formula number 12, but this one becomes 1x to the power minus 1 plus sine of x. So I'm applying the negative exponent law there. Now look, exponential expression, power rule, x to the power. Can you see? No variable part of the denominator, trigonometric function. And because the function of x, what do we write? Function slash x, which means it's the derivative. According to the formula sheet, formula number 12, ex remains unchanged. That's why it's ex plus here, exponent x, exponent minus 1, and then formula number 14, the derivative of sine x is cos x. Let's move to the other side. Function slash x is equal to 2ex. A minus and a plus gives you a minus 1x to the power minus 2 plus cos x. Remember, I was talking about the no. In the function, there must be no variable that's part of the denominator. In the derivative, there must be no negative exponent or fractional exponent. In other words, no negative exponent. The exponent must always be positive. So that remains unchanged. Minus, that negative will move now to the bottom to become a positive, plus cos x. So I've just applied the exponent law there. Differentiate with respect to x. Y is equal to ex plus 2 ln 3 minus 10x plus 4 over 3x. Always remember, each term must be in standard form. Ex, formula number 12, it's alright. 2 ln 3, there's no x, obviously regarded as a constant. 10x, formula number 16, it's fine. 4 over, whoa. No variable part of the denominator. So, in other words, my very first step will be to write term number 4 in standard form, which means I'm going to start by saying y is equal to ex, no problem, plus 2 ln 3, no problem, minus 10x, no problem, plus 4 over 3. Please don't make your own thing here. It's not 4 over 3 because that's the constant. You only change x. It was a positive 1. When you move it up, it becomes a negative 1. Now all 4 terms are in standard form because now it's a power. Now only I can start writing down dy dx. And dy dx is equal to derivative of ex, formula number 12, remains ex. Plus, there's no x, derivative is null. Minus, derivative of tan x, formula number 16, gives you sec squared x. And then the power rule, formula number 5, 4 over 3, that's my constant, square bracket, minus 1, exponent, x, that exponent must be reduced by 1. Now I'm just going to simplify my fourth term. Ex remains unchanged, plus 0 minus sec squared x. A minus and a plus gives you a minus 4 over 3 x to the power minus 2. Remember, in the derivative, no negative powers. So, finally, my answer will then be ex plus 0 minus sec squared x minus 4 over 3. That negative moves to the bottom and it then becomes positive. And that is my final answer.